Last video, here we go, arc length. This is the last thing for Calculus AB, which this arc length actually will not be on the Calculus AB AP exam, but arc length is on the BC test. So if you're in Calculus BC, this is important because there will be one or possibly two questions over it. But if you're in AB, I think it's nice to know, but ultimately it's not going to come up on your AP exam. So at the end of the day, it's not the most important. If you're curious about this page, I'm not going to do it in this video just because I don't want to. That's sorry. That's the only like explanation I really have. If you want to know kind of more about the proof, why the formula is the way it is, you can go look at my notes key. Right? You can either find that in Schoology or you can find that from my website. Go look at the PDF of my notes key, and then it's kind of walks us through. Hey, how do Riemann sums come up? How does that dx come into play for area? How does it come up for volume? And then it kind of goes through the same process. How do we generate this formula for the arc length? Go look at the notes key and you can do that, but I don't really want to do it right here. I don't want this video to be as long. I really just want to be done. So we're not going to do it, but that resource is available to you. Or if you were with me in class, I probably went through it with you in class. But just for the sake of this video, I don't want to. But ultimately, at the end of the day, you really just have to know these formulas, especially for Calc BC, because it's going to come up. And then just like how we had area and volume, we could either do a dx integral or a dy integral, and conceptually it's going to be about the same for arc length. We can find the length of the curve, aka the arc length, with a dx integral or a dy integral, but of course it would be left to right for dx and it would be bottom to top for dy. But here's the formula. It's the integral of the square root of 1 plus the derivative squared. Right? It's the integral of the square root of 1 plus f prime squared. Right? Take the derivative function squared, 1 plus the derivative squared, square root it, and then take that integral. It's Riemann sums. You're adding infinitely many things together, but really each little thing that we're adding together is the hypotenuse of a right triangle found using Pythagorean theorem. Right? That's kind of the high big picture summary of the previous page. Right? It's really Pythagorean theorem, but yeah, just a little bit faster. All right, here we go. So the integral of the square root of 1 plus the derivative squared. That's arc length. If you're curious about the process, why that formula is the way it is, you can either go look at my notes keyword, just like Google it, right? Why is the arc length formula in calculus the way it is? I just don't want to do the proof for you because it takes like an extra 5-10 minutes, and I don't want to do it. Ultimately, you just need to know the formula. Here we go. Let's do these examples, then we'll be done. Find the arc length of the graph of the given function over the indicated period. Here we go. First thing you need to do is find the derivative. So here I'm going to have 3 halves x to the 1 half, aka that's 3 root of x over 2. That's what y prime is. So here we go. Arc length, which typically is going to be denoted with the variable s. Arc length here is we're going to have the integral of the square root of 1 plus the derivative squared. This is going to be a dx integral. So I'm going to have from x equals 0 to x equals 4. And then I need 1 plus the derivative squared. Just plug in that derivative, 3 root x over 2. Bam, and you could leave it like that. Or if you wanted to simplify it, it would be 0 to 4. You have the square root of 1 plus, let's see, it would be 9 over 4x, right? That would be the same thing, dx. Either one of those, you could math 9 it, right? So we're going to math 9 it with our graphing data calculator, and then we would end up getting that the arc length here is 9.073. And kind of like the volume, they don't usually have you do these by hand because it's got that square root. Could we do it by hand? Yes. This one would just need a little bit of U substitution, but it's usually not going to make you do it by hand. Typically, you'll have a calculator, and it's either going to be set up the integral, or if they want you to do it, you'll have a calculator and you can math 9. Let's move on to the next one. Here we go. We've got y equals 3x to the 2/3 minus 10. All right. So let's go find that derivative. I would need 3 times 2/3 x to the negative 1/3, right? The derivative of that's 0, so it doesn't matter. That's going to be 2x to the negative 1/3. There's my derivative value. Let's plug it in. S equals the integral. This is going to be from 8 to 27. And then I'm going to have the square root of 1 plus the derivative squared. Let's plug in that derivative. 2x to the negative 1/3. Bam, and that would be fine. And you could type that in just as is. Or if you wanted to, right, that could be 4x to the negative 2/3. That would be the same thing. Either way, you could math 9 and end up getting 24.245. So the arc length formula, again, you will not need it for the AP Calculus AB exam. It's not on the AB exam. But if you're in BC, I almost guarantee there's going to be one multiple choice question that's an arc length. And it may come up as a part of the free response, but I kind of doubt it. It's usually just the one multiple choice. Here we go. Last two examples, and then we're done. It says, here's a multiple choice from 1998. It says, the length of the curve, y equals x cubed from 0 to 2 is given by, okay, so let's think about it, right? X cubed function looks something like this, right? It goes up on the right, comes down on the left. So if we're thinking about what's that curve length, here's like 1, 2, 3, and then it's like, okay, what's the length of this curve? We know that's up at 8, right? 2 cubed is 8, that's at 0. So we're trying to figure out what's the length of this curved section. It's not, you can't use the distance formula because it's not a straight line. But how do we find the length of the curve? Well, that's what arc length is, right? So that's our S value, or the length of that curve arc length. All right, so here we go. Remember, the formula is it's the integral of the square root of 1 plus the derivative squared. And this is a dx integral from 0 to 2. Let's check 0 to 2, 0 to 2. Okay, that doesn't rule out anything. Do I need a 2 pi out in front? Nope. Do I need a pi out in front? No, right? So 2 of the answers, terrible, right? Got them crossed off. Now let's think about what this derivative would be. F prime would be 3x squared. Therefore, f prime squared, 3x squared, that would be 9x to the 4th. Which one matches? That one. Let's see, what did this person do wrong? Part A, well, they just took the original function. They took f squared. Sorry, that's not right. This person just took f prime. So they took the derivative, but they didn't square it. This one actually took the derivative and they squared it. Easy multiple choice, right? These typically aren't super hard questions if you know the formula. Again, it's the integral of the square root of 1 plus the derivative squared. It could be a dx integral or dy, it doesn't matter. Integral of the square root, 1 plus the derivative squared. Last one. This is the length of the curve from 1 to 4 is given by, and it gives us the integral. If the curve contains the point 1,6, which of the following could be an equation for that curve? All right, so let's think about this. Let me do it in a different color. So again, we have the arc length formula. We have 1 to 4, and then I have the square root, 1 plus 9x to the 4th. Remember, this is the derivative squared. Okay, so my derivative squared is 9x to the 4th. So let's try to figure out what could the derivative have been. Well, we kind of just did it, right? It could be 3x squared, or, right, it could be negative 3x squared. Because if my original function was negative, if that derivative was negative 3x squared, right, if I were to take this and square it, the negative would go away. So it could be positive or it could be negative, right? That doesn't rule out anything. But we know the derivative is going to have to be a 3x squared. And if the derivative is a 3x squared, that means my original function f is going to have to be cubic, right? It could be a positive cubic or a negative cubic. But if the original is not cubic, then the derivative wouldn't be 3x squared, and then the derivative squared wouldn't be the 9x to the 4th. So here we go. What does this rule out? Since that is f prime squared, we know the original function must be cubic. That's wrong. That one looks okay. That one looks okay. That one looks okay. Remember, it could be negative. That one's just terrible. If you put e, that's terrible. So we think we got down to 3 options: B, C, and D. I'm like, okay, how do we decide between these 3? Well, did you catch the other piece of information that this question gave us? It said it's going to go through the 0.16. That means if I plug in 1, I need to get out 6. Let's see which one of those does that. Here, if I did plugged in 1, that one's going to work, right? So B looks good. Let's check the other one. 6 plus 1, oh, that's not right. 6 minus 1, oh, that's not right. If I plug in 1, I need to get out 6. That was the other important thing. So B is the answer. That one and that one, they kind of work for the formula, but they don't work for the point that that curve has to go. So again, this arc length stuff, ultimately, it's not the most important thing. Even on your BC exam, if you're just going to take an L on it, there's only one question, but it's a pretty easy question. If you know the formula, it's a pretty easy question. And it's kind of hard to get a 4 or 5 if you're taking L's on really easy questions. It won't come up on the AB test at all. So you just got to do the homework and then really just forget about it. It's not super important for you. But for the Calculus BC, if you just remember the formula, there's just a free multiple choice sitting out there for you, just waiting to be had. It's the integral of the square root of 1 plus the derivative squared. Do not forget that it's 1 plus the derivative squared. If you take the original function and you square it, it's going to be wrong. If you just take the derivative and leave it, it's going to be wrong. It's got to be the derivative squared, and it's 1 plus. If you know the formula, the question that you're going to see is on the AP exam is probably pretty easy. Again, the proof of it isn't super difficult. You can look at the PDF of my notes key, or if you're curious, you can ask me about it in class. I just don't want to do it in the video. Probably actually wasted more time in the video talking about it than it would have taken to actually do it, but I still want to do it. But you could always just Google it or look it up, or if you're curious, you can ask about it. That's it. That's arc length. The integral of the square root of 1 plus the derivative squared. It's a pretty short homework. You're just going to math 9 everything. So yeah, that's it. That's our last bit of content for Calculus AB. And then if you're a BC student, the next thing that we're going to do is start launching into the BC material. So sorry for you, but for Calculus AB, this means it's the last thing that we're going to learn this year. So that's kind of nice.